Now, today we are going to see the next topic. Uh, that is a bit logic here. Okay. So here in this window, we are having different instructions. You can see bit logic, comparator, converter, counter, etc. Can you see these topics one by one? So today we see bit logic. In this bit logic folder, you can see we are having different instructions here. Again, the same no MC contacts. And there's one more symbol instruction, that is not. So what is not? It's a not condition, like if your input is on, your output will be 0 reverse, and if your input is off, your output will be on. Okay, so let's see that example how to use this instruction. So here, first of all, we make this logic here to 0.1. Then I take this not instruction. Okay, so it. Now, here you can see the status of your input. 0.2 is off. What's the result of your output is here? Not condition. Your output is on, right? So, if I operate this input here, what is happening? It's reversing, right? When the input is on, output is off. Okay. For such applications, okay, for such conditions, for some conditions, we have to use reverse outputs. Okay, reverse status. For that, we can use not condition. Okay. So, NO plus not condition is equal to your NC. NC is also the same thing, right? If you take NC here, directly your output will be on. So when you operate the input, it reverses. Okay, this is only a single NC, which is equivalent to one NO contact plus not condition. Okay. Now, this is about the not. Our next instruction is midline output. This is output coil. Okay. So according to ladder logic, okay, we cannot connect two output coils in series. It is not allowed, but we can connect that in parallel. Okay, by using a branch option, we can connect them in parallel. But suppose for some conditions, if you want to use outputs in series, okay, so here Siemens has provided one condition. You can see one instruction, that is coil, output coil with hash symbol. Okay, so whenever you select any instruction here, at bottom you can see in this window, it is showing you the name of that instruction. So this is called midline output. Okay, so when you double click on this, let's see that example here. So here you can see I'm connecting this output coils in series, and in the last we have to connect one main output coil here. Okay, after connecting hash output coils, midline output coils, we have to connect this coil. Okay, this is a condition here. Now you can give the output addresses. Let's see the result here. Okay, so here your input is on. That's why all four outputs are on here. If I make the input off, all four outputs are off. So means you can control all the four outputs using a single input here. Okay, even if you connect output coils in parallel, that we also can control. Okay, but this condition output coils, you can use it in different ways. One way, connecting, sorry, inputs in parallel like this. I can drag and connect this NO here. Okay, after the first output coil. So I 0.3 here. Next, I take one more NO and drag and connect it after the second coil I0.5. Okay, so let's see this example. Now, so here when I operate I0.2, you can see all four outputs are on. Okay, if my condition is like if I operate one switch, okay, I'm having four switches. If I operate the first switch, all the four outputs should be on. If I operate only the second switch, only the second switch, only this output should be on. Then if I operate only the third switch, right, you can see. Okay, so this way we can use this midline outputs here. Another method by connecting these inputs in series. Okay, so say control X, connect after this here. X. In this method, how it works, let's see. Now, so when I operate the first input here, so only this one output is on, right? So when I operate the second input, when both the inputs are on, two inputs are on, these two outputs will be on. When I operate the third one also on, when I operate all the four inputs on, all four outputs are on. Okay. If I make any middle input off, the remaining will be off. Okay. Are you getting it? So you can connect these midline outputs in series in such conditions or in parallel also. So here the main thing is you need to understand the instruction. Means here we are seeing the not condition, right? Not instruction, how it is working. When the input is off, output of this not is on. Similarly, when the input is on, output result is off, right? So reverse. So this is how this is not instruction works. Similarly, we have seen the example with the midline output, right? How we can use that. So how it can work when the input is given, what is happening, when the input is off, what is happening, right? So that thing you have to understand here. Okay, means you have to understand the instruction, how it works. Okay, so according to our condition, according to our logic, okay, requirement, we can select our instruction. Which instruction is suitable for that particular condition, we need to select. Okay, now this is about midline output. So you see, we are having more instructions here. With symbol coils, with symbols S and R. S means set coil. Okay, set means what? If you give the input, it will set to 1. Okay, set the output to 1. So here, say Q 0.1. This. So here you can see we are seeing this latching. Okay, latching means what? Holding the output, right? Continuously on. So for that, what we are using here, we are using this output status here in parallel to your start. So this is called your latching, right? So here, similarly, we are having another way using set coil. Means this set coil is latching here itself in the output. Okay. So for this set coil, we no need to use a separate latching here in parallel to the input. So when I do the input here, I0.2, see the output is on. So when I release the input here, the output is still showing green. It will remain on until you reset this. Okay, until you reset this coil. For that, I need to take one more network, another input here, say I0.3. Here you take R, reset. Okay, so which in output you are setting Q0.1, the same output you need to reset. So here you have to take the same output address. Okay, for stop, we have to take another address. Okay. See here, it is showing green here, both because of the same output address. Now, when I give the address on I0.3, what is happening? It is resetting. See, both are off. Again, you see now, when I give I0.2 on, output is set to 1. So in case of push button, right? So when you press and release, the output should hold, right? For a push button. Similarly, for stop push button, when I press, output is off. Reset. Okay. So this is the second method for using uh, latching. Okay. Whenever you are using a push button. So this is one way. This is the second way. Okay. If in case if both the inputs are on, means set, start and stop. What is the status of your output here is off. Here you can see it is showing off. Okay. That means it is showing you the latest status of your output. Your PLC is executing the logic from top to bottom and left to right. Right. So your latest input is I0.3. For the first condition it is on, but the second latest status is off. That's why it is showing off condition. Okay. Now, so these are the coils. Okay. So we are having another method. One more method is there. We call it as flip flop. That is SR and RS flip flops. SR means set reset. You can see S and R. This is a block. Okay, set reset block. Okay. Here I can take one, I0.4. One more thing here, you can see dotted lines are there for reset. And at the top of the block, you can see question mark in red. Question mark means mandatory addresses are required. Dotted lines means optional addresses. If you want to give the address, you can give, or you can keep it empty. Okay. So I want to use it. So I'll give the address I0.5. Here we use temporary memory address. You can give output address also if you are not having any more outputs after that. Okay. So I want to use this same bit status, okay, for other outputs also. That's why I'm giving M address, okay, temporary memory where I'm storing the status of this set and reset, okay, temporarily. Then for Q, I can connect the output. That is optional. If you want to connect the output, you can connect. Otherwise, direct one output only is there. You can use output address here directly. Okay. Then Q 0.2. So how I can use this M address here? Here, M1.0. To start one more output, Q 0.3. Okay. Now, here you can see when I give I0.4, right? This set. Okay, the output is set to 1. So actually the block status is setting to 1. Okay. Now, when I release this input, still your output is on. This block is set to 1. So your output is still on. So as I have used this M1.0 here to start one more output. So the second output is also on. So where it is helpful? Okay, I did a reset here. It is off. Both the outputs are off. Now, for example, understanding, I take one NC here, I0.6. NC means breaking, right? So I will break that status here. So when I give I0.4 input and make it off, the block is set to 1. Okay, this output is starting. Now, due to some error or fault, it is breaking. What happened? This input is off, right? On here. So it is breaking here. This output is off. But as I have taken M1.0 here, it is continuing with the another output. So if my condition is like that, I'm having two motors. If the first motor is off, at least second motor should run. Okay, if the first motor is off due to some error, at least second motor should run. That's why I'm using this memory here. What happens if I take Q0.2 here to start the second output? If this motor is off, this output is off. With this, second output will also go off, right? So to avoid that, I'm using bit memory, a temporary memory. Okay, I'll just stop it. Okay. Now, so these blocks are also known as set reset flip flop. Flip flop means here interchange means alternate. Okay, so here you can use RS also. Here in this set reset, where I am set first, then reset. In this case, reset is first, then set. Okay, so what I do, set input here I 0.4, Control C, I give this in the reset. Similarly, Control C, reset input I am giving in the set. Here I take M1.1. So let's see this. Now, so for a condition like we are having push buttons for motor forward and motor reverse condition, means when I press forward button, motor should run in forward direction, and when I press reverse button, motor should stop and run in reverse direction. Okay, for such application, you can use this flip flop blocks. Okay, but what happens here? In case I am pressing both the inputs simultaneously, means forward and reverse button both are on. Here you can see for set, this is also on, whereas for reset, it is showing one. One means on, right? So here, what is the status of output? It is off because your CPU is scanning from top to bottom, right? So here, first status is set, second status is reset. So the latest status for this block is reset. So output is off. In this case, reset and set. When both inputs are on, first status is for reset, but the latest status is for set, right? So your output is on. Okay. So in case like if I press both the inputs, both the buttons, so a condition like neither it should run in forward nor it should run in reverse. Okay, means both the conditions should be in off condition. So for that, I can use, instead of using RS, I can use the same SR. Okay. So for set, I give the address 0.5, and for reset, I take 4. Okay. So download this. Okay. Now, if I press both the inputs now, you can see both the outputs are off because reset is the latest condition for that. The set input I 0.4 I am giving for reset here, right? For this reset input 0.5 I am giving for set here. You can see here. Alternately, when I make the inputs on and off, alternately this is working for forward and reverse. In case if I press both the buttons, neither forward nor reverse, right? So both the outputs are off. Okay. For such conditions, you can use this flip-flop block, SR and RS in any way. So first you have to practice this and understand the instruction, right? Now, our next instruction is positive edge and negative edge. So here I take some condition, say I 0.6, where Q 0.4. So what is positive edge? Positive edge means it generates a single pulse. Means when your input is on, for that input it generates one pulse. Pulse means it goes on and off immediately. It goes off immediately. Okay, means when the input is on, it also just goes on high and low, immediate off. Okay, so it generates only one pulse signal, one shot, we can say. So if I take this condition here like this for this output, okay, so you need to just observe here. Okay, so whenever I give the input, okay, you can see one blink. Okay, one only a single blink. Okay, it's for a short time. Just observe here. Can you see that blink? No. Okay, because we are using this output coil. Okay, open output coil. If I take the same thing for set coil here, okay, to understand that instruction, I'm taking this one, no, no, no. If I give this input now, I 0.2, observe here, okay, what is happening? See, when I given this input, this output is set to 1. Means this positive edge has given one pulse. It gone on and off immediately. Okay, so one shot it has sent to the set. Okay, that is your positive edge. Means when the input is on, then it generates one pulse. Whereas we are having negative edge, which is generating the pulse when the input is going off. When the input is on, it does not generate any pulse. When the input is off, for that it generates a pulse. That is called negative edge. Right now you can see this output is still on, right? Because it is latched here, set to 1. So when I give this input I 0.3, you can see still your output is on. Now observe here, okay, when I make this I 0.3 off, what is happening? See, when I made this off, it has sent one shot, means one pulse to the reset. It is resetting your output. Okay, so this is how your positive edge and negative edge is working here. Okay, so this is one option using this middle coils here, positive edge or negative edge. Another way you can use is blocks. Positive, POS means positive edge, NEG means negative edge. So here we have to use this in this way, block. Okay, for this control X, control V. Okay, this bit memory it is asking M bit. For this positive edge we are giving bit memory, right? The temporary bit memory status. So the same address you need to give here, bit memory address. This is the another way you can use positive edge. So when I do the input here, I 0.2, you can see it has given one shot. So this output is set to 1. When I give this I 0.3 here for negative edge, when I release the input, then only it gives a shot to the reset. Okay, so this is how these instructions are working. Okay, not midline output, set reset coil, SR or RS flip flop blocks. Okay, positive edge, negative edge, and blocks. Okay, so what you need to do is you need to practice these instructions today. Okay,